different bacteria are adapted to different wavelengths of light. For example, some grow best in red lights or green lights or blue lights or yellow lights, etc. There are some bacteria that are adapted to living in no light at all. These guys are kind of cool. You want to kill them? Turn the light on. Turn the light on, they'll let. Well, there are still other bacteria that need intense light to stay alive. They just the opposite. You want to kill these guys? Turn the light on. We also can have organisms affected by the pH. Depending on the pH depends on how well some are adapted to high pH, some are adapted to low pH. And not a big surprise, we got 3 of these. What pH do you suppose the neutrophiles like?
7.
They're like in neutral, they're around 7-ish, they're happy. We have acidophiles that like it more acidic. And we have alkaphiles that like more alkaline or more basic. Acidophiles are actually part of the reason why women have more common problems with yeast infections than do men. Not that yeast are bacteria, they're a fungi. But yeast tend to be acidophiles, they like acidic environments. The female reproductive system is more acidic because most bacteria are not acidophiles. So the female reproductive tract is made more acidic to help prevent bacterial infections, but it does make them more prone to yeast infections because of the environment that's actually created. And the last factor we have affecting bacterial growth is pressure. And there are actually 3 different kinds of pressure that can affect bacteria. One is osmotic pressure. What's osmotic pressure?
Water pressure?
No,
Wait,
not quite water
osmotic?
pressure the way you're
No.
thinking about it, I don't think.
Diffusion pressure?
Yeah.
Sort of like diffusion pressure. It's pressure caused by a difference in osmotic state. So osmotic is difference in concentrations, difference in solvent concentrations. Some bacteria can handle big differences in osmotic pressure, some cannot. And the reason I cautioned you before is because I think you were talking about this one. Hydrostatic pressure is pressure produced by water. You know that, you jump in the deep end and swim all the way down to the bottom of a 12-foot pool, what do you feel? You feel that pressure in your ears. You get in a plane and fly up, and if the plane's not being pressurized at the same speed, you get a little bit of that popping in the ears. Again, it's that's the atmospheric, but we're talking about hydrostatic, higher and lower in the water column affects that. Atmospheric is pressure caused by the atmosphere above you. There are some bacteria that live very well at Death Valley. Lots of atmospheric pressure. Bring them up to Mount Everest, they'll die. Same thing is true. There are bacteria that live at the top of Mount Everest, very little atmospheric pressure. Bring them down lower, they can't handle that. All right, any questions? I keep telling you the end is coming near because Monday is actually our last lab. And we have a lab test. Thursday next week is our last lecture. Then we get lab tests, final exams done.